Word embedding is another way of converting text into numbers. There was already one method that we have discussed, which is known as bag of words method, where we have converted text into numbers in a form of a matrix. What was that matrix that we called? Tell me. Because if we want to analyze text directly on text data, you cannot do math. You convert it to the numbers, and though on those numbers you can apply either ML models or you can apply all these mathematics. We converted text into numbers in a particular style, and this matrix that represents this text was known as what? Do you remember this matrix that we converted text into numbers? Can somebody recollect this? We converted our whole corpus at the end of the day into document term matrix. You remember this document term matrix? That is how we have converted text into number. That is one method. There, somebody has already raised a question. One question that was raised was, when you convert these text into document term matrix, this is document 1, this is document 2, and so on, this is document K, and this is a term 1, term 2, and so on, let's say term 500 or something like that. This term exists in this document, this term exists in this document, this term exists in this document. Somebody already has highlighted. What about the ordering? What about the ordering? We are kind of jumbling up ordering. It is simply bag of words, but the ordering is lost, isn't it? This particular word, let us suppose good, is appearing in here in this document. In document 10 also it is appearing, but what about the ordering? Maybe it is appearing somewhere else. So we have kind of taken away the context there. There is no context, simply which this word, whether it belongs to this one or not. It is known as like simple one hot encoding, whether this word is there in this or not, how many times it is there, like that. Now we are going to introduce a different method. Here we have converted words into numbers. Now we are going to convert each word into a vector. This method is known as word to vec. We are going to convert word into a vector. A vector means a collection of scalar values. Let's say if you have 2, 5, 9, this is a vector. Okay. So we are going to convert word into vectors. While we are converting words into vectors, we are going to keep the context intact. If you are saying these are the numerical representations of two words, this is word 1 and this is word 2. If these two are numerical representations of two words, then if they are connected with some context, then they will have similar vectors. Let us suppose one of the word is Virat Kohli, or let's say Kohli. Second word is cricket. Then those vectors will be very similar. If one word is Kohli, the second word is football, then those vectors will be very dissimilar. That means football will have a different numerical representation as Kohli. Football will have a very different representation as cricket. Maradona is another word. Then if you are converting that into numbers, this will have very dissimilar. It will be opposite to your cricket. It will be opposite to your Kohli. It will be very much similar. These numbers inside this word will be very similar. Basically, the context will be preserved and it will be like magic. Later on, if you say Sonia Gandhi, then it will be disconnected to everything else. If there is something else related to politics or anything, okay, then it will be connected to that one. We are going to see such examples in some time right now. Word to vec, converting words into vectors. First we will see what is a problem statement. What is a problem statement here? We want to perform some analysis on the text data. That's all right. We all know that. But the problem is, how do you perform analysis on the text data? Because none of the analysis can be done if unless until you convert them into numerical data. How do you convert the text into numerical data so that you can keep all the meaningful relations intact? That means context should be intact and you want to lose as less information as possible in that conversation process. You don't want to lose any information. Okay. How do you convert text data into numerical data so that very less information is lost. Let us see some of the methods. Let us start with a simple example. Let us say, I mean, why am I taking this simple example? It is very easy to understand. Later on, we will apply the same on slightly larger example. Imagine this is a corpus. King is a strong man. Queen is a wise woman. Boy is a young man. Girl is a young woman. Intentionally, we are taking very simple topics or simple sentences so that we can understand and visualize everything in front of our eyes. So these are all the sentences. We know that there are some words that are inside context. There are some words that are outside context. Let's say king and man. They should be kind of context, like king is the man, queen is not man. Queen and woman should be in the same context. When you convert these into numbers, the numbers should be in such a way that queen and woman should be kind of similar numbers. King and man should be similar numbers. The boy should be in the context of king. Girl should be in the context of queen. Prince should be your boy, or young, it should be in the context of young. Queen should be in the context of a woman. Okay. Man should be in the context of strong. Like this, we have to somehow keep the context, and it all should depend on the corpus. It's not our own intuition that we are trying to put here. It should be depending on the corpus. Whatever is the context, it should be intact. Okay. So as usual, we remove the stop words and all that. That pre-processing is done. Okay. Now here is the usual method, which is known as one-hot encoding that we do. First, we will see what is an one-hot encoding, and we will see what is the problem with one-hot encoding. In one-hot encoding, simply you take all these unique words and then you do the one-hot encoding, that young, man, king, she, was, etc., etc. All these are the words. For young, we will put 1, everything else will be 0. For man, we'll put 1 here, everything else will be 0. Now this is one-hot encoding. I think we already know what is one-hot encoding. One number will be 1 and rest all will be 0. Now why can't we convert these words into one-hot encoding here? What is the problem? If you see here, young, prince, king, woman, princess, all of them are orthogonal to each other. There is no comparison. If you say 1, 0, 0, 1, these are orthogonal to each other. 1, 0 is here, 0, 1 is here, isn't it? Now these are at multiple dimensions. If you take, those are also orthogonal. Orthogonal means no comparison at all. So that means young is not at all connected to prince. Prince is not at all connected to king. King is not at all connected to woman. Woman is not at all connected to prince. Like all these are opposite to each other, orthogonal. But if you look at it carefully, maybe young and prince, maybe young and princess, they should be in the same context, isn't it? King and man should be in the same context. Queen and woman should be in the same context. But if you convert like this, there is absolutely no relation. Zero relationship between the words. Zero relationship. Now, to avoid this, what we can do, we are introducing word to vec. Okay. So after converting everything into one-hot encoding, if you have these words, there will be absolutely no similarity between given any two. You take any two words in this whole thing. If you take queen here, ideally queen, she, sorry, queen, she, and your wise, those are in the context of queen actually. King and man was in the same context, but here king and man, they are orthogonal to each other. That means they are not in the same context. In fact, king can be orthogonal to queen, not in the same context. King can be orthogonal to, definitely orthogonal to woman, I agree. King cannot be woman, like that. There can be orthogonality based on the data. But here everything is orthogonal to everything. Orthogonal means they are not related at all. That means if you find any type of cosine similarity or anything between them, the similarity will be resulted as 0. Okay. Where one hot encoding works, if you are handling numerical data, in that there is a categorical column. This is categorical, this is not text data. Categorical column, which has some categories, east, west, north, south. Then you convert into one hot encoding, it somewhat works because this is a categorical column. There you can convert it to one hot encoding. There is no relation, etc., between east, west, north, south. Here it is text data. It has to be dealt slightly differently. So here one hot encoding does not work. Why it does not work? The relationship between king and prince is zero. The similarity between king and man is zero when you convert to one hot encoding. Queen and princess is zero. Queen and woman is zero. Now that's a problem. You cannot say queen and woman have zero relation. They have some relation, isn't it? That is the issue with one hot encoding. What to do? What is the solution? Let us check that. So we need a new representation, a representation that can preserve the word relations. If I give two words, if they are related, that means they should have similar representation. Or if I can give some similarity measure, there should be higher similarity between these two words. If there are two words that are not related, there should be dissimilarity between these two words. A simple example is if I take holy versus cricket, and let's say Maradona and football. The relationship between Maradona and football should be very high. The relationship between Maradona and cricket should be very low. Kohli and football should be very low. Kohli and cricket should be very high. Can we really convert like this? Yes, we can. Very much yes. You'll be surprised to know the results later on. The method that we are going to follow is actually not only do this, it can do even magic, something like this. If you say India and Delhi, okay, then you say China and you give space here. You say India and Delhi have some kind of similarity. Now I'm giving you China, fill it automatically based on your representation, fill something related to this. Can you guess what will be filled here? Automatically based on the relation, the one that has a similar relation in China with the blank one will be, it will automatically fill the capital of China, Beijing here. Okay, or maybe a city of China, not exactly capital, it depends on the corpus also. A city from China will be filled here. Okay, something similar to that. If you say India and Modi, China and fill something here, automatically a political leader from China will be filled here. Okay, let us check that how it is done. So the representation that are going to be coming out should be somewhat like there should be king is close to prince and man. They should be in a similar context. Similarly, queen, princess, woman, they should be close to each other. How do you make that? Okay. So how do you, first of all, like the question that was asked by Submit, how do you get the context? What is context? Bhai, batao pehle. What is context? Context is a latent, that means hidden information. Context, see, let us suppose I gave you a newspaper. Think about this, all of you. I gave you a newspaper, asked you, give me the context. How will you get the context? Tell me. I gave you this one paragraph, simple paragraph, and I asked you, give me the context. Do you think context will be written as a word there? Context ye hai, this is the one. Or context is hidden inside this whole information. How do you give me the context? Tell me. You read 4 or 5 lines, or you read 4 or 5 words at least. Yeah, we have to derive it from reading, isn't it? That means you cannot get the context. Just a second. You cannot get the context just by looking at one word. Do you agree with that point? You have to look at a window of words. Sometimes by reading one sentence, I can get the context. I don't need to read even the whole paragraph. So what is a context? It's a window of words. That is context. A context means consecutively 4 words, consecutively 5 words, or consecutively 10 words. If you take, then that becomes context. Internally it will be there, like some meaning you have to derive it, but how do you get the context? What is context in general? A window of words. We'll get the context by looking at the surrounding words. Okay, somebody wrote bank, somewhere else bank is also there. How will you get the context? Somebody told, I am standing in the queue in front of a bank, it's a very long queue, etc., etc. Somebody told, I am enjoying this evening good breeze by the side of a river bank. Now this bank is in a different context, this bank is in a different context, isn't it? If you read these words that are surrounding, then you will get to know this river bank, this is the context of river, holiday context, this is a context of bank, and in the context of banking and the money, isn't it? So here is the idea to connect words to context. How do you connect it? So as of now, word is a single word, context is a window of words. Here is the methodology. Let me explain you the whole idea of connecting words to the context.